Next, I'm going to demonstrate what we call the partial quotients division method. With partial quotients, it's going to look like long division as we start, but right away, you're going to notice some differences. The first thing we do is we draw a line down the side. This is going to separate how I'm dividing by the actual subtraction that I do inside here. So instead of in long division where we put the numbers up here, we actually use the numbers out here. Now with partial quotients, it goes hand in hand with friendly number strategy because I'm going to use friendly numbers. Instead of trying to get 8 to go right into 185, I'm going to take portions away. Basically, the idea here is to kind of chip away at the 185 until I get to a number that would be a reasonable remainder or 0 as my remainder. So I think 8 times what would give me something close to 185. 10 is a good friendly number. So if I use 10, I think 10 times 8 is 80, and then I do my subtraction. Now, we wouldn't have to start with 10 here. We could certainly start with a 20 if we realize that that puts us closer. We could use 5. The only thing we don't want to use is we don't want to get too exact. If we see like a 17 out here, that would mean that I'm doing a little too much work because then I would have to come over on the side and have to multiply 17 times 8 out. The goal here is to be able to do most of this work mentally. So I do my subtraction. And now I look at it again. I have 105. I can go 10 times again. So I simply do it a second time. 5 minus 0, 5, 10 minus 8, 2. Now I can't go that many times again, so this time I think 8 into 25. I can go 3 times. Notice I'm trying to line everything up here, keep my 1s lined up, my 10s lined up, and I also like to line up what I'm dividing by right next to what I got. So 3 times 8 is 24. 25 minus 24 is 1. Since 8 won't go into 1, I know I can stop. Over here, I add up my numbers, 10 plus 10 plus 3, giving me 23. That's my whole number. And I remember to bring my remainder back up, so I get 23, remainder 1. The idea here, again, is not to try to solve the problem all at once, but to kind of chip away at it and to realize that there's different ways to get there. Even if I started with a 20 here or a 5 here, if I do all my work right, I'll still get the right answer, whereas in long division, if you don't divide in correctly the first time, there's really no way to get back to the right answer. The next time we're going to try it with some bigger numbers to show how it works even better for larger numbers. Now here we're going to try the partial quotients method again, this time with a larger number. 2 digits going into 4 digits. This is where I think partial quotients really has a major advantage over traditional long division. I draw my line down the side, and I start to think of friendly numbers. First I might think, will 143s fit in? 143s being 4,300, that won't fit in. That might be a good starting point because at this point I can either go down to 10, which is a real easy friendly number for the students to work with, or I might find somewhere in between. Because 143s is 4,300, I could cut that in half in theory and go with 50, but in this case I think a friendlier number will be that 10. Just to prove that this will work, I'll do 10. That's 430. I do my subtraction. And now I have 2,385. Now what we tell the students is to be careful here and realize that if you're still dealing with a large number, perhaps maybe instead of 10 this time, try 20. That might go a little quicker. 10 will work, and we can do 10 the whole time, but the problem is we either run out of space or we start to make mistakes as the problem gets longer and longer. So 10 43s was 430, we're just going to double it. So we have 860. And again, the whole idea here is to be able to do most of this math mentally, to not to have to come out on the side and multiply. 5 minus 0, 5, 8 minus 6, 2, and 13 minus 8, 5, and a 1. I can do 20 again. And again, I'm just chipping away, little by little, trying to get down to a remainder that makes sense. Now I notice I can't go 20 times again, but I do know I can go 10 times once again. And this is getting long, and it does seem to be, taking a while, but I'm not really having to do a whole lot of math on the side, not a whole lot of thinking, not a whole lot of mistakes, hopefully, that I'll make. 5 minus 0, 5, 6 minus 3, 3, and 2. Now when I get to this point, I have a couple of options. I can try to split 430 in half. That might be a good idea because I have 10 Instead, I might want to do 5, and if I break my 430 in half, I have 215. And now I'm down to 20. Now I notice that my 43 can't go into 20, so I can stop at this point here. However, I'm not finished because I need to add everything back together and not forget my remainder. Have my zeros, and again, if I line this up, it makes life a lot easier. Hopefully 65 is what I get, and I don't forget to bring my remainder back up, which is 20. So that's the partial quotients method for division. Again, the idea is just to use friendly numbers to divide up my large dividend slowly until eventually I get to my correct answer.